space news, astronomers just used JWST to observe 44 individual stars in a galaxy 6.5 billion light years away. That's like 36 sextillion miles. It's that many kilometers. And I need you to appreciate how wild that is. When we observe galaxies, we're seeing a lot of starlight, but we're not seeing individual stars. Each one of these things is a galaxy, and you can see that they're kind of just like hazy blobs. You can't pick out the individual stars because they're so far away. But as it turns out, in this weird long galaxy, you can. It's called the Dragon Arc, and it's weirdly shaped because it's being gravitationally lensed. Light from that Dragon galaxy is passing by this giant cluster that's in between us and it. The gravity of this cluster warps space, turning it into a sort of magnifying glass, so the light from this galaxy gets magnified, but it also gets weirdly stretched out and distorted. But while most of the lensing is coming from this big cluster, we also get something called microlensing. There are rogue stars floating between the galaxies in this cluster, and when one of them passes in front of the Dragon Arc, it creates another little mini lens. It's a combination of the big cluster plus the microlens that allows us to see individual stars. But it's hard to notice them when you're just looking at one image. So actually how they do it is they took 2 observations of the Dragon Arc, one in 2022 and one in 2023. And they looked for changes, things they could see in one year but not the other. This shows the difference. They essentially just subtracted one of those observations from the other. The blue dots were visible in 2022, but not 2023, and the red dots are the inverse. And while there are a lot of little differences, there were 45 that were significant. They think one of those was actually a supernova that went off, and so there were 44 individual stars that became temporarily lensed and thus visible in one year and not the other. Finding 44 microlens stars in a single galaxy has never been done before. Getting these individual detections allows us to better understand how stellar populations have changed over time and what stars looked like in other galaxies long ago. It's also really useful when it comes to studying dark matter and the structure of these giant clusters. And finally, it's yet another example of how JWST is changing the landscape of astronomy. We're seeing things we were never able to see before. It's an exciting time.